Hi, I'm David with General Air. Metal cord wires have a significant advantage over solid wires in the way that they're built. They're a tubular wire that's filled with iron powder and different alloys that mix in with the weld to give the weld its desired mechanical properties. Since metal cord wire is a tube, most of the current rides on the outer edge of the wire, giving it a higher current density over solid wire. Metal cord wire can also be pulsed and welded out of position. Now, so can solid wire, but metal cord wire, since it has that higher current density, is much smoother and easier to control when you're pulsing it vertical up or overhead. Today we're going to talk about some techniques and settings on your machine and how to manipulate the torch to get a perfect pulse vertical up metal core weld. Since we're going to be pulsing today, our parameters of the machine will look a bit odd. You have a wire feed speed, which most people are familiar with in a wire fed process. It dictates your amperage. But then you have this, arc length. What does 0.8 really represent? Well, in this machine, a Pipeworks 400, we have a computer-controlled waveform. What the arc length setting does is it changes your voltage behind the scenes. Since in a pulse you have a background voltage and a peak voltage that complements a background amperage and a peak amperage, and those change at certain frequencies depending on your wire feed speed. So now we've set our machine on pulse, 155 inches a minute with a 0.8 arc length. So then what we'll do is we'll keep our wire pointed upwards and we'll go left pause, right pause, left pause, right pause, and we'll just work our way from the bottom of the plate to the top of the plate. We'll be wanting to watch the sides of the puddle and watch the root of the weld to make sure that we're getting penetration. And here's the end result, a vertical up pulsed metal cord weld. So we move from point A to point B, we move left pause, right pause, left pause, right pause, trying to overcome gravity. But the pulse of the machine helped us keep that puddle cool and solidify as we're walking up, so we can just stack the weld on top of weld. And you'll see the little dots all over the weld. Those are silicon islands that was inside the weld, and those pull out all the impurities and they float to the top, and you can just knock them off with a wire brush. But the important part of this weld is getting at the root here, so this seam, making sure you penetrate that, and making sure you fill enough on the sides. If you don't fill enough on the sides, by pausing, you'll get undercut throughout the whole length of the weld.